In this video, we're going to discuss a relationship in which a dependent variable is a linear function of the reciprocal of x. The basic form of this function would be the dependent variable y is equal to beta 0 plus beta 1 times 1 over x plus ui. As in the previous video, this is a relationship that is linear in parameters, but is not linear in variables. So in order to estimate this relationship, we need to transform it. And the obvious transformation is to create a new variable z, which equals 1 over x, and we substitute that into the equation so that we get a linear relationship between our dependent variable and this newly created variable z. But to understand this relationship, it helps if we look at some graphs. Here I've added two examples. The example on the left is one where beta 1 is assumed to be positive. The example on the right is where beta 1 is assumed to be negative. Because of the reciprocal term in there, as x increases, 1 over x decreases. As x decreases, 1 over x increases. So as a result, when x is relatively small, then 1 over x is very large, and the impact of beta 1 is very large. And if we look at the diagram on the left, this function will approach positive infinity as x approaches 0. However, as x tends towards a positive infinity, 1 over x becomes arbitrarily small, and the value of that term will approach 0. So when we use a reciprocal relationship, if beta 1 is positive, we have a relationship which in the limit is infinite as x approaches 0, and it will decline as x increases. And in particular, it will asymptotically approach 0 as x approaches positive infinity. In the diagram on the right, we're assuming that beta 1 is negative. And when beta 1 is negative, we're now subtracting a term which is arbitrarily large as x approaches 0. And it will converge to 0 as x approaches positive infinity. An interesting point here is that in a reciprocal relationship, when we estimate the equation, a positive value for beta 1 means that there is an inverse or a reciprocal relationship between y and x. Similarly, if we get an estimated value of beta 1 which is negative, that implies that as x increases, y will increase as well. In either case, whether beta 1 is positive or negative, a characteristic of this reciprocal relationship is that as x becomes large, the value of the dependent variable will converge to the value beta 0. So in a model such as this, beta 0 can be thought of as the limiting case of the dependent variable as x tends towards infinity. One of the first cases where this was used in econometrics was in estimating a Phillips curve relationship between the rate of inflation and the unemployment rate. And if we have inflation on the vertical axis, then beta 0 would be interpreted as a lower bound on the level of inflation. So it would be the level of inflation below which the inflation rate would not go. Having a reciprocal function in our set of tools that we can use will allow us to use linear regression techniques to estimate a relationship which is very clearly not a linear relationship. In particular, you may use a reciprocal model if, as x tends towards 0, the dependent variable tends towards either positive or negative infinity, and as x tends towards positive infinity, the dependent variable converges to a specific constant, which is measured by that intercept term, beta 0.